Week 5's homework is on capacitors, and that is Unit 20 in the 6th edition and Unit 19 in the 7th edition. The actual homework questions to do are based on the 6th edition, and I listed those in D2L for those of you that have the 7th edition. Excuse me. So let's go through the homework questions. Number 1. What is the dielectric? The dielectric is the insulation between the plates. Number 2. List 3 factors that determine the capacitance of a capacitor. Those 3 things are here. The surface area of the plates, that's the actual size of the plates. The bigger the plates, the more capacitance. The second one is the distance between those 2 plates. The closer the plates are to each other, the greater the capacitance. And the third factor is the type of dielectric, or whatever that material is in between the 2 plates. Number 3. A capacitor uses air as a dielectric and has a capacitance of 3 microfarads. A dielectric material is inserted between the plates without changing the spacing, and the capacitance becomes 15 microfarads. What is the dielectric constant of this material? So this is explained in the 6th edition. It's explained on page 488, section 20-3. In the 7th edition, it's page 462, section 19-3. And here's the math up here. We'll redo it. So if the first plate, the first capacitor has a capacitance of 3 microfarads, and then if we insert a dielectric between those 2 plates, so the size of the plates are the same and the distance between the plates is the same. The only thing that changed is the dielectric, and the new capacitance is 15 microfarads. So to determine the dielectric constant, and again this is explained in these sections in the 2 different editions, we do some simple division. It's 15 microfarads over 3 microfarads. So the dielectric constant of that dielectric that we put into the second capacitor is 5. Number 4. In what form is the energy of a capacitor stored? It's stored as an electrostatic field. Number 5, we have a circuit with 4 capacitors, and they're connected in parallel. We see that here. And we have the values of the 4 capacitors. They're 20, 50, 40, and 60 microfarads. And if you look at Appendix B, or in the chapter, when capacitors are connected in parallel, we can simply add them up. That's what we have here. When we do add them up, we end up with 170 microfarads. And number 6, we have those same 4 capacitors in the previous question, but now they're connected in series. So to calculate the total capacitance, it's again Appendix B or in the chapter reading. It's this formula here. And if we do this math, we end up with this value here, 8.955 microfarads.